All right, hello everyone. I just want to take the time to show you how to do this packet. This is packet 3 from our Math 1A Semester 2 class that I'm calling it a functions class because we're learning a lot about graphing and how to write equations that ultimately are functions. And some of you guys might be wondering, okay, why is this even important? When you learn how to write linear functions or any type of function, and we're learning how to write in standard form, slope intercept form, point slope form, all these different types of forms, you're learning how to essentially code. And I know technology is increasing every single day and getting better. I'm not saying that you might want to learn how to write code or like for apps or programs, video games, but at least it gives you an idea of how things work and how things change within the functions of those devices and programs and games and all of that. So we're just going to go ahead and get started. So get your packet. This is part 1, writing linear functions. That's what I call it. And we're going to focus on linear functions because they're the easiest. We can always upgrade and get better with like exponential functions and all kinds of other functions, but for now we're starting with linear functions. They're the easiest ones. A linear function is a straight line, and one of the interesting things about a linear line is that you always have to have a beginning. So here's the starting point, okay, 0 comma b. And again, it doesn't have to be b the variable. It can change to something else. Then after a starting point, this is a consistent pattern that keeps going on over and over and over, at least for this line. And this is unique to not just linear functions, but other types of functions. So there's a starting point and then there's a pattern. And we call the pattern a slope, okay? A slope usually refers to something like a mountain, you know, how steep a mountain is. The y-intercept, that's what we call the start. And the pattern is always in front of an x, okay? The variable x. So whatever the number is in front of this x, that's the slope, also considered the pattern. So this is the pattern, this is the slope. This, the number that's all by itself with no x, that's what we call the starting point or the y-intercept. So this makes it easy for us to identify the pattern and the starting point. All you have to see is, okay, identify the x, what's in front of the x, whatever that number is, that's the pattern. What's the number by itself? That's the starting point. So let's go ahead and do some examples. So right here, A, example A, what's the slope? It's the number in front of the x, so 3. What's the y-intercept? The number by itself. And so this is not difficult. This is easy, you guys. So slope, -2. Y-intercept, 9. Now, if we ever don't have a number in front of an x, that's just the 1, okay? And our y-intercept is 4. So I would want you to do some examples where we write an equation given some information. So they give us a 3 as a slope and a y-intercept as a 5. So this is so easy to write. It's just 3x plus 5. The next one, this is a fraction, 2 over 3. So 2 over 3 is the slope. So I need to put an x next to it. And then -7. -4 over 3. So let's write that down. We'll put an x, signify the slope, plus 8. -3 over, -1 over 3, x, and then the intercept is another fraction. It's a half. Don't be fooled if I flip the y-intercept and the slope, okay? the y-intercept still stays by itself. The slope is the one that has the x. So I'm going to write negative 2x plus 4. Same thing over here, 9x plus 6. We can also write equations given a graph. We need to know the slope. The slope is the pattern. So you need to count how many points going up, how many points going across, and that's the pattern. So it goes up 1, 2, 3, and over 1, 2, 3, 4. So we always start off with how much it moves up and then across. So this is actually 3 over 4x. And our y-intercept is 2, because this is where it crosses, 0, 2. Remember, at the top, the b is the y-intercept. See, the b. Okay, so it's the second number when we have the first number being a 0. Let's see the pattern. 1, 2, 3, 4. 1, 2, 3, 4. So this is 4 over 4. That equals 1. So you could write 4 over 4x plus, and then our y-intercept is 1. That's a little messy. I recommend that we just write y equals 1x plus 1. That's better. This is a different type of slope. This is a negative slope. We're going to learn a little bit more about, we're going to reintroduce ourselves to this later. But this is going down 1, 2, 3, 4, and then across 2. So negative 4, 2. We always read a graph from left to right. So we're like scanning it like a Terminator. But anyways, our y-intercept is 6. Remember the 0 and then the number next to that, that's the y-intercept. But our slope is negative 4 over 2x plus 6. And if we simplify this, this is y equals negative 2x plus 6. Okay? Let's continue. Flip the page. Let me know if you guys have any questions. I'm going to introduce this formula in several parts throughout this packet. Slope is m. So anytime you see an m, that means slope. And slope is rise over run. And then the rise is the change in the y values. So how much you up and down. And then the change in the x, that's the run. And that's how much you move left and right. So, and the formula is y2 minus y1 over x2 minus x1. This just means that you subtract the y's and you subtract the x's. That's what that means. So we're subtracting these. And if we want to write an equation, we just have to first find the slope and then the y-intercept. Now we already know the y-intercepts. I made these easy for you guys. Look, see how it says 0? The y-intercept's always the number next to the 1. I mean next to the 0. So that's a 1. This one over here is a 5. And this one's a 6. Okay, so we know all the y-intercepts, the starting points. So these are the y's. We just need to find the slope. And what we're going to do to find the slope, we could graph them, just so you know. We could graph these points 0, 1, 0, 1, 2, 7, 1, 2, 1, 2, 3, 4, 5, 6, 7. And so this is a straight line that goes like that. But if I want to know the slope, I could just count 1, 2, 3, 4, 5, 6. 6 and then over 2. So the slope is 6 over 2, which simplifies to 3. But what we just did right now is the same thing of like using this formula. So let's label. I'm going to label this one as x1, y1, x2, y2. We subtract the y's. So I'm just going to do this way. So 7 minus 1, 2 minus 0. That's 6 over 2. And notice that's the same thing we did over here. So you can use a formula or you could graph to get the slope. So, but I already know the slope. It's 3 and I already know the y-intercept. So this is y equals 3x plus 1. 3 because of the slope, 1 because of the number next to the 0. So you can do either or. It doesn't really matter. I kind of want to do both. I know that sounds dumb. But 0, 5, 3, 6. There's my line. It's kind of sloppy. My slope goes up 1 over 3, so my slope is 1/3. I'm going to use a formula just to double check. So xy, xy. I'm just going to subtract the 5 from the 6. So 5 minus 6, 0 minus 3. This is -1 over -3. Negative over negative makes positive, so that's 1/3. So it's the same thing, okay? So this is y equals 1/3 x plus, what's our y-intercept? Next to the 0, 5, okay? So I'm going to let you do this one on your own. See if you can figure it out. You can graph or you can use the formula. It's the same thing. I want to go ahead and look at number 4 and 5. Says you start a bank account with $1,000. So let's just say this is $1,000. So every one of these squares is 500 bucks. And then you keep adding 500 bucks each month. So this is just going to be constant. Okay, you keep getting 500 bucks each month. So this is going to be y equals, our pattern is 500 bucks a month. So that's 500x. And we start with 1,000. So we say plus 1,000. So that's the equation of this real life example. So this is how you guys would do calculations on how much money you're going to have in the future. Now, something fun for you to do is get a plant, measure, see how tall that plant is, and then measure how much it grows each week. So I'm going to say this plant is 2 inches tall, so that's 2 inches, and it grows half an inch each week. So half, 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 half every week. So this is y equals 1/2 x. The 1/2 is the pattern, and it starts at 2 inches, so plus 2. That's it. See if you guys can come up with a pattern in real life, something similar to this. If you can't think of anything special, you can use examples like these, but I just need one. And keep in mind, it has to be a constant rate of growth, and it has to have a beginning, a start. Okay, let's go ahead and flip the page. We are now in part 2. This is slope-intercept form. I think it's the easiest form. We actually were already using slope-intercept form. It's this right here. It's y equals mx plus b. This is called slope-intercept form. This is what most teachers teach. Again, the m is the slope, and the b is the y-intercept. Okay? This is the pattern. And this is the start. Okay? I'm just basically re-emphasizing what you learned the day before, or if you're watching this video, what you just learned. There are several types of slope. We read a graph from left to right. And so if a graph is going up from left to right, we call this positive slope. If it's going down, it's negative slope. If it's flat, this is zero slope. And if it's going straight up, we call that undefined. So in mathematics, this is where you're dividing by 0 and it doesn't work. But that's some basic stuff for you guys to remember. So positive slope, negative slope. Zero slope's the easiest. That's what we like. We like to walk on flat ground. Most people don't like going uphill or downhill, and most people definitely don't like ladders. This is probably the most favorited type of slope in real life. Now, these are simple. Identify the slope and the y-intercept. Just what's the number in front of the x? 3. What's the number by itself? 7. And this is positive, by the way. This is a -2. So -2 is the slope. Our start is at 9. I think you guys can do this on your own, okay? But if you forgot what kind of slope you have if you don't have a number in front of an x, that's a 1. And then this is a 4 is the y-intercept. This one's interesting. What happens if there's no x? If we have no x, that's 0 slope. So this is actually a flat line, believe it or not. So 0, and then your start is an 8. And since it's a 0 slope, it always stays at 8. It's a flat line. If we don't have a number by itself, that means the starting point is 0. Remember, this slope is 1. This slope is 1/2. Starting point is 9. If you flip things around, don't get confused. The slope is always the number in front of the x, and in this case it's -5. The number by itself is the slope. If there's no number on the side, that's 0. For the y-intercept, slope is always the number in front of the x, so -1/3. Okay? Hopefully this is easy for you guys. Let's flip the page one more time. We got plenty of delta math too, so make sure you guys do your delta math assignments. Ooh, here's our formula one more time. Slope is m, so anytime you see an m, that means slope. It stands for a French word, I think it's monte, which kind of means like hill in France, or French. Don't quote me, I could be wrong, it's been a while. It's rise over run, the change of y over the change of x. All of these are the same thing, and then this is the formula. So it says, this is simple, just find the slope. I just want you guys to just find the slope. So we count up, 1, 2, 3, over 1. So our slope is 3 over 1, or just 3. You don't have to write the 1 on the bottom. That's fine. When we're finding slope, we need to find the change in x and in the change in, well, the change in y and x. So this one goes up, and then over 1, 2, 3. So this is 1 over 3. And notice these are two very different slopes, so you need to make sure you guys get this right. 1 over 3 is not the same as 3 over 1. These are two different slopes, okay? If you're in a car, you definitely don't want to drive up this, okay? Slope. If you ever see it going down, that's negative. So go ahead and put the negative right off the bat. This goes down 1, 2, 3 over 2, so -3 over 2. That's our slope. And I did mention we do need the change in both x and in y. So if you see it as a table, you still need to count the slope of the x. This is +1, +1, +1. This is -5, -5, -5. The change in y goes on top, -5 over 1. That becomes -5, okay? So the reason I gave these problems is because I want you guys to remember that even though the y's are on the bottom, the y change goes on top. So this one's interesting because this goes +1, +2, +3. Huh. There's no linear pattern here. This is +4, +4, +4. We can't write this slope. This is not linear. We will learn more about this later. But notice the pattern has to be constant. -5, -5, -5, +1, +1, +1. This one was +4, +4, +4. But this was going +1, +2, +3. This is not a linear function. And so we can't write slope because it doesn't have a slope. This is more like a, like it's growing fast versus it being a straight line. Number 6, plus 2 plus 2 plus 2 plus 3 plus 3 plus 3. Change in y goes on top, so the plus 3 goes on top, and then the 2 goes on the bottom. So this is just 3 over 2. That's our slope. Hope you guys are learning a lot. We're going to now do some graphing. So this is interesting. Our graph is 2x plus 3. The 3, the number by itself tells us where we start. So we're going to start at 1, 2, 3. I'm going to go ahead and put a dot there. And then the 2 tells me I go up to 1, 2 over 1, because technically there's a 1 on the bottom. And we just follow this pattern, up 2 over 1. You can also go in reverse, down 2 over 1. And so this is down 2 over 1. I'm going to go ahead and draw a straight line. I really should be using a ruler so that you guys can see that I can draw straight lines. This is positive slope, and it starts at 3. Let's take a look at this. Next example, minus 2 means I go down 2 from the origin. This is called the origin. And then our pattern is up 1 over 3. So up 1 over 3, up 1 over 3. And I'm going to do my best to draw a straight line. There we go. Now, see if you want can do number 9 on your own. You can pause this video. Remember everything that I taught you. You're starting at 5. So 1, 2, 3, 4, 5. And then this is a negative slope, down 2 over 3. 1, 2, 1, 2, 3. Down 2 over 3. And you really only need 2 points to draw a straight line. But if you don't have a ruler, it's better to make more points. So this was a really cool chapter or section in the chapter. You guys learned about how to identify if something's linear or not. And then you guys also learned how to graph, which is cool. Let's continue. Standard form. Now, standard form is the same way, but just rewritten. So it's usually seen in this form: ax plus ax plus by equals c, where a, b, and c are real numbers, and they have a purpose. Okay, if you want to find out what the y-intercept is, then you make x equals 0, and so this really just becomes by equals c, and you solve for y. So this, you divide both sides by b, and you cancel that, and you get y equals cb. Okay. And then on this side, if you want to find the x-intercept, then you make the y value 0, and so you're left with ax equals c. You divide both sides by a, and you get x equals c over a. So I'll show you guys what I mean in just a little bit. But first, let's see what these horizontal and vertical lines are all about. Trying to see if I have a ruler. And nice, I got a ruler so that you guys don't have to see me writing some or graphing some nasty lines. But let's find out where x equals 3. So this is the x-axis, the one that goes left and right. So you just got to count 1, 2, 3. So this means x is always equal to 3. So where is x always equal to 3? In this vertical straight line. So whenever you see x equals, this is a vertical line. Whenever you see y equals, that's going to be a horizontal line. So x equals 1, right there. Y equals 5. 1, 2, 3, 4, 5. These are going to be the horizontal. Y equals 2. 1, 2. do our best to draw a straight line. Okay. Now, why is standard form useful? I explained it earlier, but let's see it in action. Okay. It says, find the x and y intercepts of the following graphs. So if I want to know the x and y intercepts of these equations, I'm going to make the x is 0 and then the y is 0, but one at a time. So let's cancel these, and so we'll get 2y equals 12. The y-intercept is at 6. So y-intercept. X-intercept, we make this, we cancel this one, and we're left with 3x equals 12. These are actually kind of fun if you think about it, if you know what to do. X equals what's 12 divided by 3, 4. So we got our two y-intercepts. Okay, and I'm going to show you on the next page why this is so cool. So let's do the same thing 3 more times. So basically I'm just going to write minus 5y equals 20, 4x equals 20. So the 20 stay, we're just canceling one and then we're canceling the other. And so then you just simplify. Divide both sides by -5. It's the same thing. Y equals -5. That's -4. Divide both sides by 4. Get y equals 5. Okay. Take a break and see if you guys can do these on your own, because trust me, this is fun. I actually really enjoy these, and it doesn't matter if you solve for y's on the top and then the x's, but you got to keep track of which is what in intersection. So I'll show you that on the next page. But let's see if you guys can do these on your own. Continue. So 3y equals 24. Divide both sides by 3. This is y equals 8. -4x equals 24. Divide both sides by -4. This is x equals -6. -8y equals 4. And x equals 4. So this one's easy. I don't even have to do any math. This is just telling me x equals 4. So nice. And then this one, divide both sides by -8. This is going to give me y equals -1/2. Okay. Now let's put this in action. So turn the page. It says use the intercepts to graph the equations. So, okay, this is our x-axis. This is our y-axis. I want to know when it crosses the y and when it crosses the x. So how is this useful? So I'm going to cancel out the 3y. So let's just do 4x equals 12. If y equals 0, this is y equals 0, and we divide both sides by 4 to get x by itself, this is x equals 3. So that means x intersects right here, 1, 2, 3. And you only need 2 points to graph a line. So if I find out what's the y-intercept, I can draw a straight line. So 3y equals 12. Divide both sides by 3. Sorry, my writing looks a little nasty. Y equals 4. So I count 1, 2, 3, 4. Only need 2 points to draw a straight line. Boom. This is why standard form is really useful. Like, you find the y-intercept, the x-intercept, boom, straight line. Let's do this one more time. And for me, it's easy. These I think all of these examples might have a negative slope, at least these two. Negative slopes are easier to start off for. So let's do 16x equals 64. 8y equals 64. Divide both sides by 16. X equals 4. Divide both sides by 8. Y equals 8. What are the odds of that? So y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. X equals 4. 1, 2, 3, 4. 2 points. Draw a straight line. That's it. Maybe just draw some arrows. That's it. 2 more examples. You guys want to try it on your own? Pause the video. Negative 5x equals 15. 3y equals 15. Solve for x, solve for y. Divide both sides by negative 5. X equals negative 3. So 1, 2, 3. There's a point. Divide both sides by 3. Y equals 5. 1, 2, 3, 4, 5. Draw a straight line. And we're starting with linear lines, but just know that we learned in the last chapter that there's all kinds of different types. These are the easiest. Now in this case, we have no x. We're just going to solve for y. Y equals 5. So that means this is a straight line. 1, 2, 3, 4, 5. There's no x. So we just care about the y. So there's no x-intercept. That's it. Okay. These are the same one. 8y equals 40 is the same thing as saying y equals 5. So this is that equation right here. Let me know if you have any questions, but we're almost done with this packet. We are now on the last part, part 4. This is point slope form. It's also useful, so keep in mind, we're learning about 3 different types. Linear slope, that's easy because if you know the slope, slope-intercept form, if you know the slope and you know the intercept, that's easy to write. Standard form is for when you know the intersections or you're trying to find the intersections. And then this one's interesting because this one is called point slope. If you know one point and you know the slope, then you can write the equation. So let's go ahead and get to it. So this is slope intercept. You've seen this already twice. I'm now trying to teach you guys point slope form. Now, definitely this looks way harder or way weirder than this. This does have a point. It's the intercept point. It's when it crosses the y-axis, okay? So whether it crosses here, or there, that's this, okay? Now, what happens if you don't know where it crosses or where it starts and you just know a random point anywhere on here? Well, that's when you use point slope form, okay? Now, it's very easy to use. You just have to remember that because these are minuses, you always have to flip the sign. So what am I saying? Well, look, the slope is the m. It's the m. It's the number outside the parentheses. So I can identify slope. It's the number outside of parentheses. See these parentheses? It's on the outside. It's the 3. But what's the point? I'm going to put parentheses, comma. What goes in here? X minus 7. X minus x1. This is the point. So this is 7, comma, and then the y1, that's the y value for the point. Y minus 3, 3. Now you might say, Mr. Martinez, isn't this supposed to be negative and negative? The answer is no, okay? You're always going to be flipping it, okay? Because the x1 is what's positive. The minus is part of the form. It's included. It makes things easier in the long run. You'll learn eventually. Now, you might also get confused because you might say, hey, Mr. Martinez, why is the y in the front and the x in the back, but then we put the 7 first and then the y goes second? Remember, when it comes to a point, the x always goes first and then the y. Always. Always, always, always. X is how you move left and right. That goes first and then the y goes second. So just keep that in mind, okay? Slope is 5. Point is 9. Ooh, but see how this is a positive? So that you got to flip it. So this is really minus 9, comma, minus 2. Slope over here is 1/3. Point is -4, +9. So that's going to be a tough one. You're going to have to remember to switch it up. The signs, because remember, these negatives are part of the formula. So it says write an equation in point slope form. So point slope form is what we just learned. Point slope form. So I'm going to write y minus, what's my y value? 4. What's my slope? 3. What's my x value? 2. Okay, so this is y minus 4 equals 3 times x minus 2. Hopefully this is easy, but it might take you some time to getting used to it because this is definitely new. You can just plug in stuff, the stuff you know. So slope is 2/3, so I'm going to put the 2/3 in front of the parentheses. The -1 is for the x, so that goes right here. So this becomes actually +1. And then the 5 goes over there. So this is y minus 5 equals 2/3 times x plus 1. Okay. Whew. Lots of stuff to learn today, right? So -2 is the slope. Slope over here is 2. So I'm going to put the 2 over here. This is my x and that's my y. So x is 6, so -6 minus 7. These are negatives, so these are going to turn into positive. So my x value is -5, so this is +5. And this is +1. Okay? Now, I'm starting off with giving you some easy ones. We're going to write an equation for the given graphs using the y-intercept. So remember, y-intercept is anytime you see a 0 as your x value. So 0, that's our y-intercept. 0, that's our y-intercept. 0, that's our y-intercept. And I'm going to show you how it's essentially the same thing. So we're going to write y minus, what's our y value? Our y value is 2. So y minus 2 equals, we need to know the slope. Because remember, this is slope, and then we put a parentheses x minus the x. So in this case, it's a 0 minus 0. But what's our slope? This goes up 1, 2, 3, 4 over 1, 2, 3. So our slope is 4/3. X minus 0 is 0. So this is really y minus 2 equals 4/3x. So this is in point slope form. But I want you guys to know that you can rewrite this as a slope intercept. If we just get rid of this -2, you would add 2. So this is the same thing as saying y equals 4/3x plus 2. Check that out. That's the y-intercept, and that's your slope. So it's easy to go from slope intercept to point slope. It's the same thing, but you're just moving things around. All right, let's not use the 0, 1 this time. Let's use this, the one without the 0. What's our y value? 9. So -9 equals, what's our slope? We got to count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Our slope is 8/4, but that simplifies to just 2. So this is equals 2 parentheses x minus, what's the x value that we used? If you use 9 as your y, then you have to use the corresponding x for that point. So this is -4. Okay? Now, I don't care which one you guys use for these points. You can use any points, but go ahead and do this one on your own. Okay? I'm trying not to do all the problems. That way you guys are forced to do some of them, and then you guys can always ask me if you got it right. It would only take me a couple seconds to know if you guys did it correctly or not. Ooh, so I'm like really having you guys remember this. Slope equals m. M is rise over run. And the rise is the change in the y's, which is really just subtracting the y's or counting. This is just counting. If you have the graph. And then the change in the x is subtracting the x's or just counting how far you go from one to the other. Okay? So write an equation of a line that passes through the given points in slope-intercept form. Now, I don't know if that's a typo. I think I probably should have said point slope. But who cares? We're just going to go ahead and listen to the instructions. So I need to use the formula. What's the formula? Y minus y's of 1 equals slope times x minus x of 1. Okay? So I just got to basically find out all the different things. I need to find out the slope, and then I got to replace the point. Now, I don't care which point you guys want to choose. Let's say I want to choose 13 over 2. 13 comma 2. So 13 is the x. I don't know the slope. M times x minus our x is 13. And then our y is 2. So this is y minus 2. But I need the slope. Okay? I don't have the slope. So I have to use this formula. So let's subtract the y's and let's subtract the x's. xy, xy, and I usually tell students label them, like which one's which. So if you want this point to be 1, then that point is 1. If you want this point to be 2, then label it as such. And it doesn't matter, you guys can flip these around. But since I made this one my second point, I'm going to write 2. We're doing some math on the side. 2 minus y sub 1 is negative 1. Minus minus turns positive, so it's actually 2 plus 1. X of 2 is 13. 13 minus x of 1. X of 1, so minus 7. So this is 3 over 6, which is just equal to 1/2. So I can rewrite this as y minus 2 equals 1/2 times x minus 13. Now I think this says to do slope-intercept. So if we wanted to do slope-intercept, we have to do a little bit of math. I don't know if I like the fact that this is a half and the 13. So let's actually redo this. But instead of using this point, let's use this point. So let's do y minus negative 1, that turns to a positive 1, equals, the slope stays the same, but now we're going to write x minus the x, which is a 7. Okay? Now keep in mind, it didn't matter if we use this example A or example B for this point or that point, you're still going to get the same answer. Okay? But I just wanted to show you guys that it's the same. Okay? So we're going to multiply the 1/2 to both terms. So this is 1/2 x, and then half of 7 is negative 3.5. Y plus 1. And I can add 1 to both sides. Subtract. We're trying to get rid of the y, the number next to the y. So minus 1, minus 1. And so this cancels out, and we're left with y equals 1/2 x minus 4.5. Now, what if we would have just continued with this other example? Would we get the same thing? Well, we have to first multiply the 1/2 across to both sides. And so this is y minus 2 equals 1/2 x, and half of 13 is 6.5. You don't believe me? Get a calculator, so check it out. So 1/2 minus 13 is, or 1/2 times 1 1/2 times negative 13 is negative 6.5. And then we want to get rid of this minus 2, so we add 2 to both sides. This cancels, and we're left with y equals 1/2 x minus 4.5. So see, it doesn't matter what point you use for point slope form. You're still going to get the same answer. Okay? Now, I do think that this is a lot more work than what I've been making you guys do. But it's only because you first have to find the slope, and then you use the point slope form, and then you go to slope intercept form. So I'm gonna let you guys do this one, which I actually think is the easiest one. Okay. My happy faces are not that happy. But anyways, I think it's like, I don't know if you can tell, the happy face is like, oh no, Mr. Martinez, I don't really want to do all the work, but it's not that bad. Let's find the slope first. So subtract the y's and then subtract the x's. So we're going to do, let's do 13 minus 19. So 13 minus 19, and that means we're going to do 5 minus negative 5. So that becomes a plus. And so then this is 13 minus negative 19, or 13 minus 19, that's negative 6. And then this becomes 10. This simplifies to negative 3 over 5. So this is our slope. Now we just use point slope form. It doesn't matter which one of these points you use. I'm going to use this one because that one has a negative, even though the negative is going to turn to a positive. You remember that? But this is y minus 13 equals negative 3 over 5 x minus 5. I need to first simplify this, so I'm going to multiply this across. This becomes negative 3 over 5x, and then if I multiply that times that, the 5's cancel, the negatives turn into a positive, and so this turns into positive 3. Y minus 13 on this side stays the same. I need to get rid of this 13, so I add 13 to both sides. So my formula is y equals negative 3 over 5x plus 16. So lots of work. I almost still kind of want to do this one for you guys. So let's see if we can just plug it in here. So we need to find the slope first. So subtract the y's. So that's 5 minus 5. Ooh, this is going to give us 0. X minus x. And it doesn't really matter what's on the bottom if you think about it. So minus 4 minus plus 2. Because this is 0 over whatever number. That's just equal to 0. So you didn't even have to do this. Slope is 0. Okay? That's actually going to be easy for us. Because what's going to happen is we're going to plug in either of these points into the formula. Y minus y1 equals slope times x minus x1. We already know that this is 0, so this is going to turn everything 0. So this is just 0, and then this is y minus. Doesn't matter which y you pick, because look, it's the same y, 5 and 5. So minus 5. Add 5 to both sides, and you get y equals 5. So that's it. You guys were all scared, and it turns out this one was the easiest one. Okay? Now, it doesn't matter if you're looking at a function or an equation. This is a function. See how there's an F? Remember I taught you guys this last week? If you ever see a letter and then a parentheses and a number, you got to think function right off the bat, okay? You can rewrite this as a points if it makes it easier. This is just x, comma y. So this is 3 comma negative 1. And then this is 2 comma 2. And then this one's going to be 5 comma 7, negative 2 comma 0. So we want to find the slope first. So label x, y, x, y. We'll make this a 1, this a 2. We'll subtract this y with that y. So 2 minus negative 1 turns into a positive. 2 minus 3 This is 3 over -1, so our slope is a -3. Okay, so that's our slope. Now we can pick either of these points. I'm going to go ahead and pick the 2, 2, just because I think that seems easier. So I'm going to write y minus 2 equals -3 times x minus 2. The 2, 2 comes from this point. The slope is right here, so that goes in there. We're going to simplify all of this. This becomes -3x plus 6, because the -3 times the -2 is positive. Y minus 2 equals this. Add 2 to both sides. This cancels, and you get y equals -3x plus 8. What does this mean? The pattern is a -3, and it starts at 8. Okay? Let's do one more and we're done. Find the slope. xy, xy, make this 1, make this 2. So we do 0 minus 7. Okay, and if you don't know what I'm doing right now, it's this formula. I'm subtracting the y's and subtracting the x's. So I subtract the 0 minus the 7, and now the minus 2 minus the 5. This gives me -7 over -7, so that's just equal to +1. So that's an easy slope. It doesn't matter what point I use. I'm going to use this one because there's a 0. So this is y minus y1 equals slope times x minus x1. I already know the y1. Well, actually, I guess I labeled this one the y1, but I'm going to use my y1 to be my y2 because there's a 0. So this is just y minus 0 equals my slope of 1 times x minus my x, a -2, which turns positive. So this just turns to y equals x plus 2. And that's it. Super, super simple. Make sure you guys ask me for help if you need help. It's easy, but there's a lot of stuff that we learned this week. It's crucial that you guys understand the different types of formats for the linear equations. And also keep in mind that you guys have a lot of Delta Math assignments this week, okay? So just go ahead and do your assignments. Ask me if you guys need help. Give this video a like and comment and share if you guys want to share with some of your friends or your parents so you guys can see that your teacher is doing some videos. Hope you guys have a great week. I'll see you guys tomorrow at school.